Hello everyone, this is a lab report going over Newton's second law and how it could be applied to real world situations. So before we want to go into this experiment, we need to find out what is Newton's second law. And as quoted by Newton, the change of momentum of a body is proportional to the impulse impressed on the body and it happens along the straight line on which the straight line is impressed. And this is true for all forces and not valid for systems with non-constant mass. Okay, so for the purpose of this lab, we want to see how Newton's second law can be used to predict an object's future position. And in order to do this, we're going to conduct an experiment and compare it to a model to see how accurate the model is when Newton's second law is applied. All right, so for the experiment, we're going to be moving a small cart on a rail. Now, we're conducting an experiment like this, you want to identify your system and surroundings. In this case, the system is a cart, and the surroundings are everything else, such as the rail itself and the hand that pushed the cart. After recording the cart being pushed, I went back and recorded the position of the cart after each frame in the video, which produced these numbers you see in the chart to the right. Now we're going to use these numbers to calculate the velocity of the moving cart. So here I'll be using data from the table to calculate the velocity of the moving object. In order to calculate the velocity, you want to have a start time and an end time with a position at each respective time. In this case, I'm using 0 seconds as my start and the position at that time, which is 0.01312 meters along the x-axis, and the time passed after one frame as my end, which is 0.033 seconds, and the position at that time, which is 0.0149 meters along the x-axis. Now that I have my values that I want to use, I can use the velocity formula to calculate the velocity. Now, this is found by dividing the change of position by the change in time. As you can see there, it's represented by delta r over delta t. So when we're doing this, we have the final position minus the initial position, and we're dividing that by the final time minus the initial time. So I got my vectors subtracted from each other on the top, and I got my time subtracted from each other on the bottom. Now, once we do those calculations, we come up with a velocity of 0.35 meters per second. Now, these are some code snippets that I have. So now that we have the velocity, I'm going to use everything I have up to this point to make a code in order to model the experiment that was conducted. Now, first I want to make sure my initial position and velocity are correct, and they can be identified by ball.pos and ball.vel. Now I'm going to set my start time at 0 seconds using the variable t, and the change in time at 0.033 seconds using the variable delta t. Now that we have our initial conditions, we can create a while loop. Now the loop is going to end at 1.183 seconds because that's the length of the video we recorded for the experiment. And within the while loop, we're going to update the position and velocity after each change in time using position and velocity update formulas. Now the velocity update formula is indicated by using ball.vel, and it consists of adding the velocity to the net force over mass multiplied by the change in time, as you can see on the right side of the screen. And the position update formula is similar, except we're adding the position to the velocity times the change in time. So basically what this is going to do is after each change of time, which is 0.033 seconds, is going to go through and calculate the velocity and the position at that respective time. It's going to keep on going over and over again until we reach 1.183 seconds, then it's going to stop. So after running the code, we finally have all our data that we can compare. Now the red line represents the model and the blue dots represent the recordings from the video. And as you can see, the results from the two are nearly identical, which shows that Newton's second law works with predicting the object's future position and time. Now, after we've run this experiment, we can come to the conclusion. And assuming that all of the calculations are correct, the velocity and position update formulas can accurately predict where an object will be after a certain period of time. But be cautious that there can be errors conducting these types of experiments that can lead to inaccurate predictions, such as the change in net force or the mass of the object or other factors like friction and all that kind of jazz, which can change the velocity and it could possibly skew the model from the actual experiment and give you inaccurate numbers. So that was my lab report, and I hope you enjoyed the video.